Hello friends and my dear students, I welcome you all to my channel. I hope you are all doing well and also your studies are also going on well. In this video I will start the next chapter, that is properties of parallel lines. So this is part 1 video on the chapter properties of parallel lines, where I will discuss the fundamental properties of parallel lines, that is what are parallel lines and what is a transversal and the angles formed by a transversal cutting two parallel lines. And finally I will solve the problems of exercise 14 from the textbook of author R.S. Aggarwal. So this video is part of the playlist CBSE Mathematics for class 7 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay, so I have my rough notes prepared on the left hand side on the properties of parallel lines, and I will refer my notes while doing the discussion. And on the right hand side I have the canvas where I will write and discuss the concepts of properties of parallel lines, and I have copied all the problems from the exercise 14 from the textbook on the canvas itself. I have drawn the figure based, mostly all the problems are figure based, so I have copied down, I have written down the problems and the necessary information given, the figure and the necessary information given in each problem, and I will solve here. Okay, so let's start discussing the concepts of the properties of parallel lines. Now first, what are parallel lines? You might have already learned a bit about parallel lines and angles in your previous class. So two lines L and M are said to be parallel if they lie on the same plane and they do not intersect, no matter how far they are extended on either side. So we have a line, let's say this is a line, and this is also a line. Now these two lines are looking parallel, let's say they are parallel. So we diagrammatically draw a line like this. We have the two arrowheads on both the ends, meaning it's a line, it can extend endlessly on either side, and we denote each such a line with a letter L or M. So the first line is L and the second line is M, and they are parallel if these lines do not intersect at any point, no matter how far you extend both the lines. So if I extend the line L on the right hand side, it will go like this, and if I extend the line L on the left hand side, it will go like this. Similarly, if I extend the line M, it will go like this and it will go like this, but they will never intersect. So this is the property of two parallel lines. They never intersect, no matter how far you extend either side of the lines. And of course these two lines should be in the same plane, and we denote mathematically, we express that line L and M are parallel with the symbol two parallel lines. So this means line L and M are parallel to each other. Okay, now as you can see on the notes in the second diagram, the line L and M are not parallel because if you extend the two lines on the right hand side, on the right ends, they are intersecting at a point, so they are not parallel. Okay, now if the distance between so this is point number 1. I have written all the properties of the parallel lines point wise, so I will discuss point wise. So point number 1 was the basic definition of two parallel lines. Point number 2 is the distance between two parallel lines L and M is same everywhere, meaning, so let's say these two lines L and M are parallel. So how do we find the distance of a point on line M, on line L from the line M. So let's say P is a point on the line L, and I want to find the distance of the point P on the line L from the line M. So what I will do, I will draw from the point P, I will draw a perpendicular. I will draw a perpendicular on the line M. So this is perpendicular meaning this is 90 degree. Let's say this point, the perpendicular, the point at which the perpendicular is intersecting the line M is, let's say, Q. So PQ is the distance of the line L from the line M. Now if you take any other point, similarly if you take any other point P dash on the line L, and if you want to find the distance of the point P dash from line M, you will drop a perpendicular on the line M, and let's say the perpendicular intersects the line M at point Q dash. So P dash Q dash is the distance of the point P dash on L from the line M. So we will have, since L and M are parallel lines, we will have PQ equals to P dash Q dash. PQ is the distance of the point P on the line L from line M, and P dash Q dash is the distance from the line M from the point P dash on L. So this is the property number 2, that distance between two parallel lines is same everywhere. So meaning if you take any point on one line, and if you find the distance of that point from the other parallel line, it will be same. Okay, now let's see point number 3. Point number 3 describes this is the definition of a transversal. So what is a transversal? A transversal is a line that intersects two or more lines at distinct points. It is very important that you understand the definition. A transversal is a line, so it is a line which will intersect two or more, at least it should intersect two lines, but at distinct points. So in the figure you can see I have line L and also I have line M. So let's say I have in the figure on the notes, in the notes you see I have line L and I have line M. They seem to be parallel, but it is not necessary that they need be parallel. They should be parallel, but they may not be parallel. Now I have the line P. As you can see, it is intersecting the line L at the point A. It is only intersecting the line L at the point A. So the line P is not a transversal, because a transversal need to intersect at least two lines, but the line P is intersecting only one line, which is L. So P is not a transversal. Consider the transversal T. The line T is intersecting the line L and M at the point B and C, and also the line N on T. The line T is intersecting the line L, M and N at the point B, C and D. So it is intersecting more than two lines and at distinct points. The distinct points are B, C and D. Therefore T is a transversal. Consider the line Q. It is intersecting the line L at the point F. It is intersecting the line M at the point E, and also it is intersecting the line N at point E. So the line Q is intersecting three lines. But it is intersecting at the same point. It is intersecting the line M and N at the same point, which is E, but it is intersecting the line L and M at two different points, F and E. So Q is also a transversal because it is intersecting with at least two lines at distinct points. Now if you consider the line R, it is also intersecting the line M and N at the point E, but at the same point E. So R is not a transversal. I hope it is clear what is a transversal. A transversal is a line that need to intersect with at least two other lines, and the points of intersection with the other two lines has to be distinct. Okay. Now let's see point number 4. Point number 4 is the angles created by a transversal in cutting two parallel lines. So if a transversal is intersecting two parallel lines, then what are the angles formed? So in the diagram you can see the L and M are parallel lines and T is the transversal. Which is intersecting the line L and M, of course, at distinct points. Now, what are the angles formed? We need to understand some angles that are formed. The first one is the pairs of corresponding angles. There are some pairs of angles, meaning first is the corresponding angles. Now, there are 4 pairs of corresponding angles. Now, what are corresponding angles? In the figure you will see that the angle 1 and 2 are corresponding angles. They are corresponding angles. Now, there is nothing to understand what are corresponding angles or these types of angles. You just have to know them. You just have to remember. So, if let's say we have two parallel lines, let's say A and B, this is a line, not A and B. Let's say we have two lines L and M, and we have a transversal intersecting these two lines. Let's say transversal with T. So this angle, so what are corresponding angles? This angle and this angle is one pair of corresponding angles. So let's say I am denoting the angle as, numbering the angles as 1 and 2. This is how we identify angles. We use some numbers. So this 1 and 2, angle 1 and 2 is one pair of corresponding angles. What are other pairs of corresponding angles? This one, this angle, let's say this angle be 2. This angle and this angle is also corresponding angles. Sorry, not this angle. This angle and this angle, angle 2 and angle 3 are also corresponding angles. Now there are two other corresponding angles. Consider this angle as 4 and 5 are corresponding angles. Angle 4 and angle 5 are corresponding angles. Now the numbering I am using on the right hand side may not match with what I have used in the notes. So please do not try to match them. Just listen what I am saying. So, and the last pair of corresponding angles is this angle, let's say be 6, and we have this angle 7. Okay. Now I think you will clearly understand in the notes what are the corresponding angles. I have highlighted the corresponding angles with the same color. So angle 1 and 2 are corresponding angles. They are in blue. And the green angles, that is 3 and 4, they are also a pair of corresponding angles. And angle 7 and 8 are also pair of corresponding angles. And finally angle 5 and 6 are pair of corresponding angles. Okay. So this is pairs of corresponding angles. Next is pairs of alternating interior angles. So you can see the parallel lines L and M and the transversal T, the alternating interior angles. So angle 1, it is an interior angle. By interior angle means it is within the two parallel lines, not outside the parallel lines. It is within the two parallel lines. So angle 1, its alternating interior angle is angle 2. Similarly, for angle 3, its alternating interior angle is angle 4. There is nothing much to understand. You just have to remember and know that which angles are corresponding angles, which angles are alternating interior angles. And the next is pairs of alternating exterior angles. So pairs of alternating exterior angles are the angle 3 and the angle 4. Similarly, the angle 1 and angle 2, they are alternating exterior angles. Since these angles are outside, it is not within the line, between the line L and M, but they are outside outside the region enclosed by the line L and M. Okay, so these are alternating exterior angles. Another angles are pairs of consecutive interior angles. These angles are also interior angles because these angles lie within the between the line L and M. So as you can see, the angle 1 and 2, they are one pair of consecutive interior angle, and the angle 3 and 4, they are also other pair of consecutive interior angle. And the important thing to note is that the sum of a pair of interior consecutive interior angles is 180 degree. So angle 1 plus angle 2 is 180 degree. Also angle 3 plus angle 4 is 180 degree. Now consecutive interior angles are also known as co-interior angles. Consecutive in short is known as co. So co-interior angles means consecutive interior angles. So these are the types of angles formed by a transversal intersecting two parallel lines. These you have to remember, and basically remember, there is nothing much to understand. You just have to know them and remember them. Now, when a transversal intersects two parallel lines, we have these angles formed. Now, if the reverse is true, that is, if a transversal is intersecting two lines L and M, but they are not, but we do not know whether they are parallel or not, then also okay, one thing I forgot to tell is that all pair of corresponding angles are equal. That is, angle 1 is equal to angle 2, angle 3 is equal to angle 4, angle 3 is equal to angle 4, angle 7 is equal to angle 8, and angle 5 is equal to angle 6. That is, all pair of corresponding angles are equal. Similarly, every pair of alternating interior angles are also equal. That is, angle 3 is equal to angle 4, angle 1 is equal to angle 2. This is very, very super important. Also, the pair of alternating exterior angles are also equal. That is, angle 3 is equal to angle 4 and angle 1 is equal to angle 2. So, pair of corresponding angles are equal, pair of alternating interior angles are equal, and pair of alternating exterior angles are equal. But in case of consecutive interior angles, they are not equal, but their sum is equal to 180 degree. Now, point number 5 says, properties 5 says that if you are given two lines L and M and there is a transversal cutting these two lines L and M, so obviously we will have the corresponding angles, we will have the alternating interior angles, we will have the alternating exterior angles, and also we will have consecutive interior angles, but we cannot tell whether a pair of corresponding angles are equal or not, or a pair of alternating interior angles or a pair of alternating exterior angles are equal or not. We do not know. We cannot say until and unless it is given that the lines L and M are parallel. But if it is not said that the lines L and M are not parallel, we can only say that the lines, we can only infer, or we can tell for sure that the lines L and M are equal, L and M are parallel only if any one of the following conditions, that is condition A, B and C, any one of these condition is true. That is, condition A is any pair of consecutive angles are equal. If you find, so we have a transversal T cutting two lines L and M. Now, if you find any two corresponding angles are equal, then I can say the lines L and M are parallel. Or if I see any any pair of alternating interior angles are equal, then also I can say that line L and M are parallel. Or if I see the sum of the pairs of consecutive interior angle is 180 degree, then also I can say that the two lines L and M are parallel. So that is all for the theoretical aspects, all the concepts of properties of parallel lines. What are parallel lines? What the definition of a transversal, and the angles formed by a transversal when it cuts to parallel lines, and that when a transversal cuts to parallel lines, we have all pair of consecutive angles are equal, all pair of interior alternating angles are equal, all pair of alternating exterior angles are equal, and the sum of pair of interior consecutive angles is 180 degree. So okay, now let's with this concept let's try to solve the problems from exercise 14. Okay, so I have written down all the problems of exercise 14 and left a space for solving the problem. Okay, so the problem number 1, so all the problems are figure based. You have to understand the figure very clearly and the information given, and we have to solve it. So in the first problems, it is given that the lines L and M are parallel. So we have this. It is given that line L is parallel to M. So we see line L and M are parallel. We also see a transversal T is cutting the lines L and M, and we have the angles formed. That is 1, 2, 3, 4. All the angles are numbered 1, 2, 3, 4, 5, 6, 7, 8. And it is given that angle 5 is 70 degree. Angle 5 is 70 degree, and we have to find the angle 1348. Now angle 5 is equal to angle 1 because they are corresponding angles. T is a transversal, L and M, since L and M, lines L and M are parallel, and T is a transversal cutting them, intersecting them. So we clearly see that angles 1 and 5 is a pair of corresponding angles. So we must have angle 5 is equal to angle 1. This is equal to 70 degree. So we have found that angle 1 is 70 degree. Okay. Now if angle 1 is 70 degree, we can clearly say that angle 1 and angle 3 are vertically opposite angles. In the previous chapter, lines and angles, we know that vertically opposite angles are equal. Why angle 1 and 3 are vertically opposite angles? Because we see that the line L and T are intersecting at this point. Let's say this point be O, and let's say this point be P. So we can clearly say that angle 1 and angle 3 are vertically opposite angles, so they should be equal. So this implies that angle 3 is equal to angle 1, which we have already found to be 70 degree. So we have found angle 1 70 degree and angle 3 also to be 70 degree. We have to find angle 4 and 8. 4 and 8. Okay. Now since we also know, since the angle 1 and angle 4 are linear pair, Why? Because we can see that the angle 1 and angle 4 are formed on the line T and on the same side at the point O. So we can say that this implies that angle 1 plus angle 4 should be equal to 180 degree, because we know that the sum of a pair of linear angles is 180 degree. So this implies angle 1 we know is 70 degree. So 70 degree plus angle 4 equals 180 degree. This implies angle 4 is equal to 180 degree minus 70 degree, which is 110 degree. So angle 4 is 110 degree. Okay, now we have to find angle 8. Angle 8. Now we can solve angle 8 in many ways. We know that angle 8 is exterior alternating angle to angle 2. We know that angle 2 and angle 8 are pair of alternating exterior angle, alternating exterior angles. Okay, now this implies that angle 8 should be equal to angle 2. Now we have to find what is angle 2. Now angle 2 we can find from the angle 1. We know that angle 2 and angle 1 are linear pair, because they are on the same side of the line L and they are formed at the point O on the line L. So this implies angle 2 plus angle 1 is equal to 180 degree. This implies angle 2 plus angle so 1 we know is 70 degree, so this is 180 degree. Now so this implies angle 2 is 180 degree minus 70 degree, this is 110 degree. We could have also found angle 2 from angle 4, because angle 2 and angle 4 are vertically opposite angles, and since we have already found angle 4 to be 110 degree, we could have said that angle 2 is equal to angle 4, which is 110 degree. So we have found angle 2 to be 110 degree. So this implies that angle 8 is equal to angle 2, which is 110 degree. So now angle 8 is 110 degree, and we can also see that angle 4 and angle 8 are corresponding angles. From that also we could have said that angle 8 is equal to 110 degree, because angle 4 and angle 8 are corresponding angles from the definition of corresponding angles. So there are many ways you can solve a problem. It is enough that you solve the problem in one way which you feel comfortable, using vertically opposite angles, using linear pair of angles, or using the angles formed by a transversal and two parallel lines, that is corresponding angles, alternating interior angles, alternating exterior angles, and the sum of consecutive interior angles. Any concept you apply and you can solve the problem. Okay, so let's see problem number 2. Problem number 2 is given is that lines L and M are parallel, and we have a transversal intersecting the parallel lines L and M, and we have the angles, and it is given that the ratio between the angles 1 and 2 is 5:7, and we are asked to find the angle 1, 2, 3 and 4, 1, 2, 3 and 8. Okay, so now we clearly see that angle 1 and angle 2 angle 1 and angle 2 are linear pair. A linear pair, since they are on the same side of the line L at the point O, where the transversal T is intersecting the line L at the point O. So we can say that angle 1 plus angle 2 is equal to 180 degree, because the sum of a linear pair of angles is 180 degree. Now from the fact that angle 1 plus angle 2 is equal to 180 degree, and also we know that angle 1 divided by angle 2 is equal to 5 by 7. From these two facts we can always calculate the value of angle 1 and angle 2. So this is the concept of ratio and proportion. I hope if you have not completed the chapter ratio and proportion, you can watch my videos on the chapter ratio and proportion. I have thoroughly covered it with lots of problem solving in the same playlist. So from these two facts, if we have angle 1 plus angle 2 equals to 180 degree, and we know that angle 1 by the ratio of the two angles, angle 1 and angle 2 is given is as 5:7, we know that angle 1, there is a direct formula which will be the term in the ratio corresponding to angle 1, which is 5, divided by the sum of the terms, that is 5 plus 7, multiplied by the sum of the angles 1 and 2, that is 180 degree. So this is 5 by 12 into 180 degree. This is how much? 12 cancels or divides 180 with 115. So this is 75 degree. So angle 1 is 75 degree. Also we can say that angle 2 is the term in the ratio corresponding to the angle 2, which is 7, divided by the sum of the terms in the given ratio multiplied by the sum of the two quantities, that is 180 degree. This is 7 by 12 into 180 degree. This divides 15. So this is 105. So angle 2 is 105 degree and angle 1 is 75 degree. So we have found 1 as 75 degree, angle 2 as 105 degree. Now we have to find angle 3 and 8. Now what is angle 3? Angle 3 is vertically opposite to angle 1, is vertically opposite to angle 1. So this implies that angle 3 is equal to angle 1 is equal to angle 1 we have found to be 75 degree. So we have found angle 3 to be 75 degree. Now what about angle 8? Angle 8, now okay, so we know angle 2. Now angle 4 is vertically opposite to angle 2. This implies angle 4 is equal to angle 2, which is equal to 105 degree. So angle 4 is 105 degree. This implies angle 8 is also angle 8 is equal to angle 4. Why? Because angle 8 and angle 4 are corresponding angles. They are corresponding angles. So this is equal to 105. So 108 is angle 8 is 105 degree. So using the concept of vertically opposite angles, the sum of linear pair of angles is equal to 180 degree, and of course the corresponding angles and the alternating interior angles, the alternating exterior angles, and the sum of consecutive interior angles is 180 degree. Using these concepts only you can solve any problems based on parallel lines and a transversal. Okay, let's see problem number 3. So we are given two parallel lines L and M. There is a transversal intersecting them, and it is given that the angle 1 and angle 2 in terms of x. So angle 1 is equal to 2x minus 8 degree, and angle 2 is given to be 3x minus 7 degree, and we have to find angle 1 and 2. So first we have to solve x, and then when after solving x we can find angle 1 and angle 2. Okay, now how can we solve? So we can clearly see that angle 1 and angle 2 are corresponding angles. Angle 1 and angle 2 are corresponding angles which is formed by the transversal T as it is intersecting the two parallel lines L and M. So this implies a pair of corresponding angles are equal. So we have angle 1 equals to angle 2. This implies angle 1 is given as 2x minus 8 degree. So we can say that 2x minus 8 degree is equal to angle 2 is given to be 3x minus 7 degree. We can get rid of a degree and we can say that 2x minus 8 is equal to 3x minus 7. So now we have to solve this linear equation in one variable x. We will bring minus 1. How come? If we solve this, we are getting x a negative value, because we will have, if we solve this, if we bring all the x terms to the left hand side and all the constants to the right hand side, I get minus x equals 8 minus 7, this is 1. So this implies x equals to minus 1. No, the angles are having negative. Angles cannot be negative. Angle 1 and angle 2 are they are corresponding angles for sure. They are corresponding angles. So angle 1 should be equal to angle 2. So 2x minus 8 is equal to 3x minus 7. And if we solve this, we are getting x as minus 1. And if we x as minus 1, now if you put x as minus 1 in the expressions for angle 1 and 2, they will become negative. No, this is wrong. Angles cannot be negative. Let me quickly check if I copied the problem number 3 correctly or not. I might have done some. Problem number 3 is something else. What is this? Okay, yes. Two parallel lines L and M are cut by a transversal T if the interior angles of the same side of TB. If the interior angles of the same side, I did a mistake. If the interior angles of the same side, so this is not an interior angle. I guess this angle, now angle 1 and angle 2 are interior angles on the same side of the transversal, that is on the right hand side of the transversal, and the other two interior angles on the other side of the transversal would be this angle and this angle. Anyway, so angle 1 and angle 2 are, we know, are not corresponding angles, but we know they are consecutive. They are consecutive interior angles or co-interior angles. Co-interior angles. So this implies the sum of them should be 180 degree, because we know that a pair of consecutive interior angles, their sum is always 180 degree. So we must have angle 1 plus angle 2 equals 180 degree. This implies if I get rid of the degree, I will get 2x minus 8 plus 3x minus 7 equals 180. If I open the brackets, I get and simplify all the like terms, that is the terms, variable terms and the constant terms, I get 5x minus 15 equals 180. This implies 5x equals 180 plus 15, which is 195. This implies x equals 195 divided by 5. This is 39. This is 39. So this implies angle 1 is 2x minus 8. 2x minus 8 degree. This is equal to 2 into 39 minus 8 degree. This is equal to 78 degree minus 8 degree. This is 70 degree. So angle 1 is 70 degree. Also angle 2 is 3x minus 7 degree. Angle 2 is 3x minus 7 degree. So this is equal to 3 into 39 minus 7 degree. This is equal to 117 minus 7 degree. This is equal to 100 degree. So no, their sum should be equal to 180 degree. So how much is 39 multiplied by 3? 27, 11. Yeah, it's fine. Oh, this is 110. 117 minus 7 is 110 degree. So the angles are 70 degree. Angle 1 is 70 degree and angle 2 is 110 degree. Okay. So while I am solving the problem, you can pause the video and take a screenshot for your future reference. Okay, let's do problem number 4. So we are given two parallel lines L and M, and we see there are two transversals, transversal S and transversal T, as they are intersecting the two parallel lines L and M at distinct points. So, and also it is given that the line S and T are not parallel, they are not parallel. Find x and y. So some angle is given 50 degree. Okay, we are asked to find the angle x and y. Okay, now this angle, let's say this angle be angle 2. We know that okay, so we know that angle 2 is vertically opposite to the 50 degree angle. So this implies that angle 2 is also equal to 50 degree. So if the angle 2 is vertically opposite to angle 50 degree, because the line L and S are intersecting at the point, let's say this point be O. So angle 2 must be equal to angle 50. Now if angle 2 is 50 degree, we also know that angle 2 and x are consecutive or co-interior angle, or co-interior angles. uh, yes, they are co-interior angles, that is consecutive interior angles formed on the right hand side of the line of the transversal S. So this implies, we know that a pair of co-interior angles, sum of the pair of co-interior angles is equal to 180 degree. So we must have angle 2 plus x degree is equal to 180 degree. This implies angle 2 we know is 50 degree. So we have 50 degree plus x degree equals to 180 degree. This implies if we get rid of the degrees, we have 50 plus x equals 180. This implies x equals 180 minus 50. This is 130. So x is 130. X is 130. Now we have to find y. Okay. Now let's say this angle be 3 and let's say this angle be 4. Now 130. We do not know angle 4, we do not know angle 3, we know angle x. From x, what angle, what else we can't know? Angle y is, angle y and angle 3 are equal. Angle y and angle y and angle 3 are equal because they are corresponding angles formed by the transversal T with the parallel lines L and M. So we know that angle y is equal to angle 3. Also we know that what else we do know? Angle 4 plus angle 3 is 180 degree. Since they are consecutive interior angles formed by the transversal T and the parallel lines L and M. Let me see if I am missing any information. We have got angle 2 as 50 degree. So we know angle x. Now from angle x, what else can we get? Angle x. Angle x is 130. So this is 130. How can we I will check the question once again if I am missing any information or not. Oh yes, indeed I am. It is not apparent to have find the values of n, x and y. one angle is given, this angle is given to be 65. This angle is given to be 65. Now if this is so, and let this angle be 5. Now we know that since angle 5 in the diagram, angle 5 and angle 65 degree are corresponding angles formed by the transversal T with the parallel lines L and M. So we can clearly see angle 5 is equal to 65 degree. Now angle now y, also we know that angle y plus 65 degree is equal to 180 degree, because angle y and angle 5 a linear pair of angles formed on the same side of the line L at the point, let's say this point be P. So we know that angle y plus angle 5 is equal to 180 degree. This implies that this implies that y degree plus angle 5 we have already found to be 65 degree. 65 degree is equal to 180 degree. So this implies that y is equal to 180 minus 65. This is 115. So y is 115 and x is 130. Okay. Okay. Let's do problem number 5. In the problem number 5, it is said that in the triangle ABC, we have a triangle ABC and some angles are given. Of angle B is given to be 65 degree, angle C is given to be 45 degree, and it is said that the line DAE is parallel to BC. Okay, so line DAE is parallel to the line BC, that is the base of the triangle ABC, and also angle DAB is given to be x degree, and angle EAC is given to be y degree. We have to find x and y. Okay, so we know that the main information given is DAE is parallel to BC. Now we have to see, and we know that if DAE is parallel to BC, we clearly know that AB and AC are transversals to lines DAE and BC, which are parallel. So we have the transversal AB intersecting the parallel lines DAE and BC, and also the transversal AC intersecting the parallel lines DAE and BC. So now we can clearly say that this implies angle C, that is angle C of the triangle ABC, angle C and 5 degree are alternating interior angles. They are alternating interior angles formed by transversal AC. If we consider the parallel lines DAE and BC and the transversal AC, then we have the alternating interior angles C and y degree. This implies y degree equal to angle C. This implies y degree is equal to angle C is given to be 45 degree. This implies that y equals 45. Now what about x? X, similarly we can say that uh, angle B of the triangle ABC and x degree are alternating interior angles. They are alternating interior angles formed by the transversal AB. So this implies x degree is equal to angle B. This implies x degree is equal to angle B is given to be 65 degree. This implies that x equals 65. So we have found x equals to 65 and y equals to 45. Okay. Let's do problem number 6. It is given that CE is parallel to AB, BA. Okay. BA is parallel to CE. Angle BAC is given to be 80 degree and angle ECD is given to be 35 degree. We have to find angle ACE, ACB and ABC. Now the fact that CE is parallel to BA implies that AC is a transversal to CE and BC, not to CE and BC, but is a transversal intersecting or cutting lines, parallel lines CE and BA. So we can see that AC is a transversal intersecting the parallel lines BA and CE. Now this implies that angle ACE and 80 degree, not 80 degree, the better way of writing the steps is angle ACE and angle BAC are pair of alternating interior angles. So angle BAC and angle ACE are pair of alternating interior angles. Since the line BA and CE are parallel and AC is the transversal, this implies that they should be equal. That is, angle ACE should be equal to angle BAC. This implies angle ACE is angle ACE is equal to 80 degree. Angle ACE is equal to 80 degree. So we have found ACE. This is 80 degree. Now we have to find ACB. Okay. So this angle we have to find. Now, so we are only focusing on the parallel lines AB, CE and the transversal AC. What else can we say? Now, also note that BD is a transversal, transversal intersecting BA and CE. BD is also a transversal intersecting AB, the parallel lines AB and CE. Therefore, this angle must be equal to 35 degree, because so this implies angle ABC and angle ECD are they are corresponding angles. The main job in solving this kind of problems is to visualize, is to understand, observe the lines and angles on the given facts properly, and to identify which are the corresponding angles for a transversal and the two parallel lines it is intersecting, to identify which are the corresponding angles, which are the alternating interior angles, which are the alternating exterior angles, and which are the consecutive interior angles. Once you identify them, then you have to only apply the properties. That is, the corresponding angles, pair of corresponding angles are equal, pair of alternating interior and alternating exterior angles are equal, and the sum of pair of consecutive interior angle is 180 degree. You have to apply these properties. So for the parallel lines BA and CE, we also see that BD is a transversal and angle ABC and angle ECD are corresponding angles. This implies that angle ABC is equal to angle ECD, which is given to be 35 degree. So we have found angle ABC. ABC is 35 degree, and we have to only find angle ACB. Now angle ACB, what is ACE? ACE we have already found to be 80 degree. So this is we have already found to be 80 degree. Now to find ACB, note that angle ACB, angle ACE and angle ECD are formed on the same side, of the line BD, and we know that the sum of all angles formed on the same side of a line is equal to 180 degree. We have learned these properties in the previous chapter on lines and angles. So this implies that angle ACB plus angle ACE plus angle ECD should be equal to 180 degree. Now angle ACB we do not know yet. So angle ACB plus angle ACE. Angle ACE is 80 degree. And what is angle ECD? Angle ECD is 35 degree, is equal to 180 degree. So this implies angle ACB is equal to 180 degree minus 80 degree minus 35 degree. This is 100 minus 35 degree, that is 65 degree. So angle ACB is 65 degree. Angle ACB is 65 degree. So it is very important that you understand the given figure properly, and understand which are the parallel lines, understand which are the transversals, and for a given transversal and the two parallel lines it is intersecting, identify the corresponding angles, or identify the alternating interior angles, identifying the alternating exterior angles, and identify the consecutive interior angles, and the fact that the corresponding angles are equal, corresponding alternating interior and exterior angles are equal. All these properties then you have to apply to solve the problem. Work slowly, step by step, and you will obviously be able to solve any given problem. The main task is to understand the given figure, what is given, what are parallel lines, which are the parallel lines, which is a transversal. So what are the corresponding angles, what are the alternating interior angles, what are the alternating exterior angles, and the fact that also you have to use the fact from the previous chapter that two vertically opposite angles are equal, sum of linear pair of angles is 180 degree. All those concepts you have to apply. Okay, let's solve question number 7. It says line AO is parallel to CD. Okay, line AO is parallel to CD, and OB is parallel to CE. Okay, OB is parallel to CB. Now if you mark, if you give some names to the lines, let's say the line OA is L, and let's say the line CD is M, this line M. So we have given L is parallel to M, and let's say the line CE be P, and let's say the line OB is Q. It is also given P parallel to Q. Okay, now clearly we see that line line Q is a transversal, intersecting the parallel lines, L and M. So line Q is a transversal intersecting the parallel lines L and M at the points O and D respectively, So this implies, now consider the line L and M, parallel lines L and M, and the line Q. Q is a transversal to the parallel lines, is a transversal intersecting the parallel lines L and M. This clearly says that we can say that angle AOD and angle CDB, angle AOD and angle CDB are corresponding angles. Are corresponding angles formed by the transversal Q, which intersects the parallel lines L and M. So this implies that angle CDB is equal to angle AOD or AOB. Angle AOD and AOB is same, equal to 50 degree. We have to find angle ECD. Okay. ECD. So angle CDB is, so this angle is 50 degree. This is also 50 degree. Now note that now we also can say that CE is parallel to DB, that is line P and Q are parallel. So we can say that M, the line M is a transversal to lines P and Q. The line M it is a transversal to the lines P and Q as it is intersecting them at distinct points, that is at point C and D. So from the transversal M intersecting the parallel lines P and Q, we can clearly see that angle CDB and angle ECD are co-interior angles or consecutive interior angles. Now we know that the sum of co-interior angles is 180 degree. So we have angle CDB plus angle ECD equals 180 degree. This implies angle CDB we have already found to be 50 degree. So 50 degree plus angle ECD is equal to 180 degree. This implies that angle ECD is equal to 180 degree minus 50 degree. This is equal to 30 degree. So angle ECD is 30 degree. Okay, so given parallel lines, you have to first identify the transversal, which is a line which is intersecting two parallel lines at distinct points. Then that line becomes a transversal, and once we have identified the two parallel lines and a transversal intersecting those two parallel lines, then you have to observe the corresponding angles or alternating interior angles or co-interior angles, that is the consecutive interior angles, and then apply the properties, that is equality of angles or the sum of angles will be equal to 180 degree. And of course never and ever forget that the concept from previous chapter, that is lines and angles, that is two vertically opposite angles are equal and the sum of linear pair of angles is 180 degree. Okay. Give me a second, I will just quickly have a little bit water. Okay, let's solve problem number 8. So in this figure it is said that AB is parallel to CD. Okay, AB is parallel to CD, fine. Angle ABO is given to be 50 degree and angle CDO is given to be 40 degree. Then it is asking find angle BOD. Find angle BOD. So let's say the angle BOD is X degree. This angle we have to find. Let's say this angle is X degree. We have to find X. Now whenever you have parallel lines, immediately identify the transversal. Now in the given figure we know that AB and CD are parallel, but we do not see any transversal. We do not see any transversal, that is a transversal is a line that will intersect two parallel lines. We have no lines here which is intersecting the parallel lines AB and CD at distinct points. If we consider OB, it is only intersecting the line AB, and if we consider OD, it is only intersecting the line CD. Okay, so what can we do? We don't have a transversal. We need a transversal to apply the properties of parallel lines, that is we need those angles formed by a transversal and a transversal intersecting two parallel lines. Only then we can apply those properties, that is corresponding angles, properties of corresponding angles, alternating interior angles, alternating exterior angles, and consecutive co-interior angles. Now if you extend, if you now we have to utilize the fact, we have to utilize the angle 50 degree and 40 degree, that is for sure. Now we have to, the main objective is to find an angle which we can relate to the angles 50 degree or 40 degree. Now if I extend this OB, extend further OB to intersect the line CD, let's say I have extended the segment, line segment OB to intersect the line CD at the point, let's say E. Now I can say that BE is a transversal that is intersecting the line, parallel lines AB and CD. BE is a transversal. Now will that help? I mean, also let's say I extend OD. Now I extend OD to intersect the line AB, let's say at the point F. So I can say that FD is a transversal. Also FD is also transversal to the line, parallel lines AB and CD. We have to find angle BOD, X. We have to find X. We have to find X. Now we have to find X. Now there might be various ways of solving a problem. You can try some other ways, but that is fine, as long as you solve the problem using one way. So by creating these two transversal, how is it helping me? BE is a transversal to the line, parallel lines AB and CD. So I can say that to find X, I need to know, now this angle I know will be 130 degree, because this angle CEB, from the fact that BE is a transversal to the parallel lines AB and CD. So the angle ABE and the interior angles ABE and the angle CEB are consecutive interior angles. So their sum should be 180 degree. So angle CEB is 130 degree. So this is 130 degree. And what else? This 40 degree, this is 40 degree, this is 40 degree. So this angle must be 40 degree as well, because the angle BFD and angle CDF are alternating interior angles. So this is 40. So we have utilized the fact only the properties of alternating interior angles. Now this is 40. if this is 30 and this is 130, this is 40, this angle we will get, but how is it helping to find x? To find x we have to know this angle, no, I will try this later on. Let's move on to the next question. Problem number 9, it is saying that the line AB is parallel to line CD. Okay. EF is transversal cutting at G and H. Okay, so line EF is a transversal to the parallel lines AB and CD intersecting at the points G and H. Okay, GL is bisector of AGH. GL is bisector of angle AGH. So meaning, if this is angle x degree, this should also be angle x degree, and HM is the bisector of angle GHD. So if this is angle y degree, this will also be angle y degree. Prove that GL is HM. GL is parallel to HM. Prove that GL is parallel to HM. Now, if GL is parallel, if we have to prove that GL is parallel to HM, we know that we have to prove either a pair of corresponding angles. Now, first we know that if there is a transversal, intersecting two lines which may not be parallel, two lines L and M intersecting at distinct points, then if we can find one pair of corresponding angles to be equal, then we can say that those two lines which is being intersected by the transversal are parallel. Or if we can find any alternating interior angle to be equal, then also the lines are parallel. Or if we can find that the sum of two consecutive interior angle is 180 degree, then also we can say the lines are parallel. Now consider so we know that so this angle AGH, since GL is a bisector of angle AGH, we know that angle AGL is equal to angle LGH equals to, we have assumed to be x degree. Also we know that since HM is a bisector of the angle GHD, we know that the angle MHD is equal to angle MHG, which we have assumed to be 5 degree. We have assumed. Now we see that now EF, this line is a transversal intersecting the lines GL and HM at distinct points G and H respectively. Okay, now so considering that EF is a transversal intersecting the lines GL and HM, we see that angle x, which we have assumed to be x degree angle x, and angle y are alternating interior angles. Now if we can show that angle x is equal to angle y, then it will be proved that GL and HM are parallel lines. Now from the original fact that AB is parallel to CD, and EF is a transversal to AB and CD, we can say that the fact that AB parallel to CD and EF is a transversal that is intersecting these two parallel lines implies we can see that angle AGH and angle GHD are alternating interior angles. Angle AGH and angle GHD, they are alternating interior angles. This implies that angle AGH we know is x plus x degree, and angle GHD is now, so this implies that they are equal. That is, angle AGH is equal to angle GHD, as they are alternating interior angles. Now this implies that x degree plus x degree equals y degree plus y degree. Angle AGH we clearly see is that angle AGH has been divided equally into two angles, and each angle is x degree. So angle AGH is x plus x degree. Similarly, angle GHD has been divided by the bisector HM into two angles, equal angles, y degree. So we can say angle GHD is equal to y degree plus y degree. Now, so this implies 2x degree equals 2y degree. This implies, of course, if we cancel 2 out, x degree equals y degree. Now since x degree is equal to y degree, and also we have seen that angle x and angle y are alternating interior angles. Are formed by the transversal EF, which intersects the lines GL and HM. Therefore it proves that GL and HM are parallel lines. So this fact, let's say this be 1, and this fact this be 2, that angle x and angle y are alternating interior angles, and that x degree is equal to y degree. It shows that GL and HM must be parallel lines, because the angle x and y are alternating interior angles formed by the transversal EF intersecting the lines GL and HM. So this proves that HL and GM are parallel lines. Okay, let's do question number 10. It says AB is parallel to CD. Okay, angle ABE is given to be 120 degree. Angle ECD is 100 degree. Angle BEC is x degree. Find x. We have to find x. So the main fact is that AB and CD is parallel. And AB and CD is parallel, AB and CD is parallel, and AB and CD is parallel, and there is a point E. We have to find the angle BEC, that is angle x degree. Now the lines BE and BE and CE now we have to find a transversal to the parallel lines CD and AB, that is for sure. Now how can we form a transversal to parallel lines CD and AB and CD? Point E. Now if we draw a parallel line, let's say this, if this be a line, let's say PQ, that is passing through the point E and parallel to the lines AB and CD, parallel to both AB and CD, then of course we can find this angle as this angle, let's say this be y degree, and let's say this be z degree. So y degree and 100 degree are co-interior angles, co-interior angles formed by the transversal CE intersecting the lines, parallel lines CD and PQ. So we can find y. Similarly we can find z, because 120 degree and the z degree, they are co-interior angles formed by the transversal BE intersecting the parallel lines AB and PQ. So we will get z. Yes, so if we get z and y, of course we can get x, because z plus x plus y will be 180 degree, as they are forming angles on the same side of the line PQ. Okay, so what we did is we draw line PQ through point E parallel to AB, and CD. So this implies that CE, this implies that PQ is parallel to CD, PQ is parallel to CD, and CE is a transversal intersecting lines PQ and CD at E and C, that is at distinct points. So this implies that angle CEQ and angle DCE are co-interior angles, So this implies, we know that the sum of the co-interior angles is equal to 180 degree. So we have CEQ plus angle DCE equals 180 degree. This implies angle CEQ is y degree, we have assumed to be y degree. Angle DCE is given to be 100 degree equals 180 degree. This implies y degree is equal to 80 degree. This implies y is equal to 80. Okay, now similarly we can see that PQ is parallel to AB and BE is a transversal intersecting the lines PQ and AB at E and B. So this implies that angle which is this point AB. Okay, so this implies angle ABE and angle BEP are co-interior. They are co-interior angles. So this implies that their sum will be equal to 180 degree. Equal to 180 degree. So this implies that ABE is given to be 120 degree. So 120 degree plus angle BEP is equal to 180 degree. So this implies angle BEP is equal to 180 degree minus 120 degree, that is 60 degree. So the BEP that is, this implies which is angle Z. So Z degree is equal to 60 degree. Z degree is equal to 60 degree. Okay. Now X degree, Y degree and Z degree are formed on same side of the line PQ. So this implies that X degree plus Y degree plus Z degree should be equal to 180 degree, because the sum of all the angles formed on the same side of a line is equal to 180 degree. We have learned this in the previous chapter on lines and angles, properties of angles. Now this implies X degree plus Y degree we have found to be 80 degree and Z as 60 degree. So 80 degree plus 60 degree equals to 180 degree. This implies that X degree equals to 180 degree minus 140 degree. This is equal to 40 degree. So we were asked to find X. This implies X equal to, X is not 40 degree, X is 40. Okay, let's do problem number 11. It says that AB is parallel to DC, okay, and AD is parallel to BC. It's a kind of parallelogram. The figure ABCD is a kind of parallelogram. Opposite lines are parallel. Prove that angle ADC. It is asking to prove that angle ADC, let this be x degree, is equal to angle ABC. This y degree. It is we have to prove x equals to y. So we have to first identify a transversal intersecting two parallel lines. Now we know that DC is parallel to AB. Let this angle be P degree and this angle be Q degree. Now this angle, it's asking prove that ADC is equal to ABC. ADC is equal to ABC. ADC is x equals to ABC. ADC is equal to ABC. Instead of now a problem, but particular problem in this kind of problem where there is figures like parallel lines and transversals and lines, and there are many ways you can solve a problem, but let's get rid of these angles x, y, z, q and p. I am thinking if I connect the points D and B, so D and B will become diagonal basically of the parallelogram ABCD, and DB will also become so now we have that DC AB is parallel to DC. AB is parallel to DC, and also we see that DB is a transversal. After joining the points D and B, the line DB is a transversal intersecting AB, the line AB and CD at B and D. So this implies that angle DBDC and angle this angle let me also this one. So this angle, let's say this be 1 and this be 2. So angle BDC and instead of writing BDC, it will be easier if we write angle 1 and angle 2 are alternating interior angles. So BD is a transversal intersecting the parallel lines DC and AB. So we have so we can see that the pair of alternating interior angles is angle 1 and 2. This implies angle 1 is equal to angle 2. This is one fact. Let's say this result be 1. Also we see that dB is also a transversal intersecting but before that we have to say that AD is parallel to BC. We know that AD is parallel to BC. Now also we see that DB, the line DB, is a transversal intersecting lines AD and BC at D and B, at point D and B. So this implies that this angle, let this angle be 3 and let this angle be 4. We see that angle 3 and angle 4 are alternating interior angles. A pair of angle 3 and 4 is a pair of alternating interior angles. So this implies that angle 3 is equal to angle 4. Now what is angle ADC? Angle ADC is equal to angle, you can clearly see that angle ADC is equal to angle 1 plus 3, 1 plus angle 3, which is equal to, if we substitute angle 1 with angle 2, we can say that angle 1, replace angle 1 with angle 2 as they are equal, and replace angle 3 with angle 4 as angle 3 and 4 are equal. So we see that angle 1 plus angle 3 is equal to angle 2 plus angle 4, which is equal to angle ABC. Hence we have proved that angle ADC is equal to angle ABC. Okay, let's do problem number 12. It is given that L and M are parallel lines. Okay, P and Q are also parallel lines. 65-degree angle is given. Find ABCD, the angles ABCD. Okay, so now I will not write too much. I will not solve the problems in too much details, writing all the steps. I will speak out what concepts I am applying, and I will just write the necessary things in solving the problem. So we know that L and M are parallel lines, and Q is clearly a transversal intersecting the line parallel lines L and M, and so it is forming. So if 65 degree, so this angle 65 degree and this angle should also be 65 degree, as they are corresponding angles formed by the transversal line Q intersecting the parallel lines L and M. So we have this 65 degree. Now clearly we can say that, and D and 65 are linear pair of angles. So we have D plus 65 is equal to 180 degree, since the sum of a linear pair of angles is 180 degree. And what are linear pair of angles? A linear pair of angles are angles formed on the same side of a line at the same point. So the line Q is forming the angles D and 65 degree on the same side of the line M. So this implies that D is equal to 180 degree minus 65 degree. This is 115 degree. So D we have found to be 115 degree. Okay, Now angle A and angle 65 degree is, angle A is vertically opposite to angle 65 degree. So this implies, we can clearly say that A is equal to 65 degree because it is vertically opposite to 65 degree. So we have got A. Now also see that the P and Q are parallel lines and L is a transversal intersecting the parallel lines P and Q. L is a the line L is a transversal to the parallel lines P and Q. So therefore this angle should be equal to 65 degree. This angle and this angle are corresponding angles. So this is 65 degree. Now and obviously B plus 65 degree should be equal to 180 degree, as angle B and this 65 degree are linear pair of angles formed by the line L on the line P, on the same side of the line P. So this implies B is equal to 180 degree minus 65 degree. This is 115 degree. So B is also 115 degree. Okay. Now if B is 116 degree, we know that now again the line P is a transversal, line P is a transversal to the parallel lines L and M, which is creating two consecutive interior angles B and C. So B and C are consecutive interior angles formed by the transversal P intersecting the parallel lines L and M. So we have B plus C equals to 180 degree. Now this implies B we have got 115 degree. So 115 degree plus C equals to 180 degree. So this implies C equals to 180 degree minus 115 degree. This is equal to 65 degree. So C is 65 degree and A we have already found to be 65 degree. Okay, so we have found ABCD. Okay, so let's do problem number 13. It says that AB is parallel to DC. AB is parallel to DC. Okay, and AD is parallel to BC. Okay, so it's a parallelogram. Angle BAC is 35 degree and angle CAD is 40 degree. AC is the diagonal. Okay, angle CAD is 40 degree. Okay, given ACB is, if the angle ACB is x degree and angle ACD is y degree, find x and y. We have to find x and y. So we have to find the angle ACB and the angle ACD. Now the fact that AD is parallel to BC, AD is parallel to BC, and clearly we see that AC is a transversal intersecting lines AD and BC at A and C. So this implies, we can see that angle CAD and angle ACB are alternating interior angle. Alternating are actually is a pair of alternating interior angles. So this implies that angle ACB is equal to angle CAD. This implies x degree is equal to angle CAD, which is given to be 40 degree. This implies that x equals 40. X equals 40. Also note that DC is parallel to AB and AC is a transversal intersecting lines DC and AB at DC and AB at CN A. C and A. So DC is parallel to AB. DC is parallel to line AB, and AC is a transversal. We can clearly see that AC is a transversal intersecting the parallel lines DC and AB at the point C and A. So this implies angle DCA and angle CAB are alternating interior angles, or angle DCA and angle CAB is a pair of alternating interior angles. This implies that angle DCA angle DCA is equal to angle CAB. Now DCA is y degree. This is equal to angle CAB. Angle CAB is 35 degree. 35 degree. So this implies that y equals 35. So x equals to 40 and y is equal to 35. Okay, let's do problem number 14. Problem number 14 says that AB is parallel to CD. AB is parallel to CD. Okay, CA is extended. AB is parallel to CD. Okay, and so we have of course CA is a transversal to the parallel line CD and AB, and also DB is a transversal to the parallel line CD and AB. Now CA has been extended. CA is extended to E, so that BAE is 125 degree. Now it has given that the angle BAC is X and angle BDC is Y degree and angle ACD is Z degree. Find XYZ. Find XYZ. Okay. So the only two parallel lines are CD and AB. CD and AB, and we know that both the line AC and BB are transversal to the parallel line CD and AB. So we know that AB is parallel to CD, and we know that AC is or rather CE, it is better to say CE is a transversal intersecting the parallel lines intersecting the parallel lines AB and CD at A and C. So CE is the transversal intersecting the lines, parallel lines CD and AB at point C and A. So this implies that angle BAE and angle ECD are corresponding angles, or they are a pair of corresponding angles. Angle BAE and angle ECD is angle 125 degree and Z degree are so this implies that 125 degree, this 125 degree and Z degree are corresponding angles, So this implies that corresponding angles are equal. So this implies Z degree equals 125 degree. This implies Z equals 125. So Z is 125. Okay. Now you can find X in two methods. X and 125 degree angle, 125 degree are linear pair of angles. So 125 degree plus X should be equal to 180 degree. Also you can say that angle X degree and Z degree are consecutive interior angles formed by the transversal CE and the parallel lines CD and AB. Now it is better if we say that you can use any method. Now X degree and 125 degree, actually it is correct way of saying is not with degrees but angle CAB and angle BAE are linear pair. This implies that angle CAB plus angle BAE will be equal to 180 degree. This implies angle CAB is X degree and angle BAE is 125 degree. 125 degree. This is equal to 180 degree. So this implies that X equals to 180 degree minus 125 degree. This is 50. This is 55 degree. So X degree is 55 degree. This implies X equals to 55 and we have already found Z equals to 125. Okay, now we have to find Y. We know now so again we know that CD is parallel to AB. CD is parallel to AB and BD is a transversal intersecting the parallel lines CD and AB at the points D and B, which are distinct. So this implies that this implies that angle CDB and angle CDB and angle ABD and angle ABD are co-interior angles, that is consecutive interior angles, and their sum should be equal to 180 degree. So angle CDB plus angle ABD is equal to 180 degree. This implies angle CDB is y degree and y degree, and angle ABD is x degree, is equal to 180 degree. This implies y degree, x is 55, so x 55 degree equals to 180 degree. This implies y equals to y degree is equal to 180 degree minus 55 degree. This is equal to 125 degree. This implies y equals to 125. So x equals to 55, y is equal to 125, and z is equal to 125. Okay, let's do problem number 15. I will drink some water, please. Okay, so problem number 15, three figures are given, 1, 2 and 3. It is saying that two lines L and M are cut by transversal T. Okay, so it is not said that whether the lines L and M are parallel or not. So there are two lines L and M in all the figures, and T is the transversal intersecting the lines L and M. Verify if L is parallel to M or not. Okay, so for all the three figures we have to verify whether the lines L and M are parallel or not. If I consider the first figure, 130 degree, the angle 130 degree and angle 40 degree are now what conditions will make the lines L and M parallel? We know that if there is a transversal intersecting two lines L and M, it will obviously form corresponding angles, it will form alternating interior angles, it will form alternating exterior angles and consecutive interior angles. Now if we see that corresponding angles, any pair of corresponding angle is equal, then the lines L and M will be parallel. Now and now we do not see, now if this is 40, we can clearly say that this angle will be 180 minus 40, that is 140. This will be 140 because these for 140 degree and 40 degree, because these two angles are linear pair of angles and they must add to 180 degree. So this is 40 degree, this angle must be 140 degree. Now if this is 140 degree, what angles can we find? Now this angle, of course this angle will obviously be 140 degree because it will be a vertically opposite angle to other 140 degree. So we have this 140 degree. Now if we can find the sum of any pair of consecutive interior angle is 180 degree, then also the lines L and M will be parallel. Now this is 140, this is 40, this is 140, this is 130. Now if this is 130 angle, this angle should be 50 degree. This angle should be 50 degree because this angle is linear, this angle and this angle are linear pair of angles, and their addition should be 180 degree. So if this is 30 degree, 130 degree, this angle should be 50 degree. Now if this is 50 degree, we know the vertically opposite angle, this must also be 50 degree. Now we clearly see that the 140 degree plus 50 degree is not adding to 180 degree, but this angle and this angle are consecutive interior angles, and their addition is not equal to 180 degree. The addition is 140 plus 50, which is 190. So clearly we can see that, we can say that L is not, I am using this symbol, not parallel to M, because if L and M are parallel, if the lines L and M would have been parallel, then of course the sum of a pair of interior angles should be 180 degree. But we can clearly see that the sum of the consecutive interior angles are 140 degree and 50 degree, and the addition is not 180 degree. So one is done. Let's see 2. Okay, now so we have this 145 degree. So this is 35 degree. Obviously this will also be vertically opposite angle, will also be 35 degree. This will be 35 degree. Now since T is a transversal intersecting the lines L and M, the angle 35 degree and this 145 degree are consecutive interior angles, and the sum is equal to 180 degree. 145 degree plus 35 degree is 180 degree, and they are consecutive interior angles. So the line for 2, the line L and M are parallel. For 3, so okay, so this is 125, and this, if this is 125, this angle should be 55, because this angle and this angle are linear pair of angles. So if this is 125 degree, this angle should be 180 minus 125, which is 55 degree. Now this angle, if L and M are parallel, then this 55 degree angle and the 60 degree angle, they are alternating interior angles and they should be equal, but they are not. So L is not parallel to, L is not, for 3, L is not parallel to M. Now I think I couldn't solve one problem which I left and thought to solve it later on. Which one is that? Is this one? No, we have already solved this. X degree equals to y degree. We have done this. This one, I guess. Yes. So it is given that line AB is parallel to line CD and ABO. Okay, so we have two lines BO and OD intersecting at the point O, and angle ABO is 50 degree given, and angle CDO is given to be 40 degree. We have to find the angle X, angle X. Now instead of doing this, instead of extending on the lines, what was given. Okay. 130 was not given. Let me. Okay, so given was this point was O. 50 degree and 40 degree was given. Okay, so we have to find X. AB is parallel to CD. AB is parallel to CD. Now we have to find a transversal for sure. We have to create a transversal. I was thinking about using the lines BO as a transversal by extending it to intersect the line CD, and also then by extending the line OD to intersect with the line AB, but it was becoming complicated. Now how can I now if I draw a parallel line, let's say if I draw a parallel line through O, let's say this be PQ, this PQ through the point O, draw line PQ through the point O parallel to AB and CD. Okay. So this implies that BO is a transversal to lines AB and PQ which are parallel. We know that we have drawn the line PQ parallel to both AB and CD. So now we can see that AB is parallel to PQ and BO is a transversal intersecting the lines AB and PQ. This implies that angle ABO and angle BOQ are alternating interior angles, angle ABO and angle BOD. So this implies they must be equal. So angle ABO is equal to angle BOQ, which is equal to 50 degree. So angle BOQ is 50 degree. Also, we know that PQ is parallel to CD, and therefore OD is a transversal intersecting the lines PQ and CD which are parallel. So this implies that OD is a transversal to the line PQ and CD. Therefore we can say that angle ODC and angle DOQ are alternating interior angles. So this implies angle ODC must be equal to angle DOQ. This implies angle ODC is given to be 40 degree. So 40 degree is equal to angle DOQ, angle DOQ 40 degree. Now see that interesting thing to note is that angle BOD is nothing but angle BOQ plus angle QOD. BOQ, did we find BOQ? Yes, BOQ we have already found to be 50 degree, and QOD and angle DOQ is same, and we have already found angle DOQ to be 40 degree. So this is equal to 90 degree. So this implies that x degree equals to 90 degree. This implies x equals 90. It was asking to find angle BOD. So angle BOD is 90 degree. So this brings to an end in solving the exercise 14. Now these problems on the properties of parallel lines and these transversals and all the angles formed by a transversal and parallel lines, transversal intersecting two parallel lines, the angles formed, the corresponding angles, alternating interior angles and alternating exterior angles, consecutive interior angles. This will be at first very a little difficult and tricky to identify and locate in a given figure. So for this you have to solve a lot of problems. Whenever two parallel lines are given, and if there is already a given transversal, that is fine. You can easily identify the corresponding angles, alternating interior angles, alternating exterior angles, or co-interior angles. But if there is, you cannot in the figure it is not not saying anything about a transversal. You have to figure out from the figure if you can find a transversal intersecting two parallel lines. So it is all about a transversal intersecting two parallel lines first of all, and then from that we have to identify the corresponding angles, the alternating interior angles and the consecutive interior angles, and the fact that a pair of corresponding angles are equal, a pair of alternating interior angles are equal, a pair of alternating exterior angles are equal, and the sum of a pair of co-interior angles is equal to 180 degree, and also the sum of identifying linear pair of angles and their sum to be 180 degree and vertically opposite angles are equal. So all these concepts, these are the concepts that you will require to master and know well to solve this kind of problem. So it will require a lot of practice. Only then you can solve a problem, because a figure given in a given problem, the figure might look little difficult to understand, but it is just that you have to practice a lot of problems, and that is having a various variety of figures and identify the parallel lines and the transversal, and then the corresponding angles, alternating interior angles, all those angles, and then use the properties of angles. So these problems in the exercise 14 are good enough. If you can solve these problems yourself, then you can believe that you have a good understanding of the concepts of parallel lines and the transversals, and how to apply the concepts of the corresponding angles, interior angles, alternating interior angles, alternating exterior angles, and all the stuff to solve a problem. But still, I will prepare two practice test paper, as I always do for all chapters. That will give, if you can solve them yourself, it is great. But even then, if you cannot solve any problem, you can see my solution and add to your knowledge base. So tomorrow I will come up with the first practice test paper on this chapter, properties of parallel lines, and day after tomorrow I will prepare another practice test paper that will bring an end to the chapter of properties of parallel lines. And to solve properties of parallel lines, you must also have a good understanding of the previous chapter, that is lines and angles. I hope this video was beneficial to you. If it is so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. So until the next video, take care and bye.